Hey everyone, welcome back to Dev Parkour. In this video, I want to tackle the question, why is authentication hard? In the last video, I talked about some of the things that I was thinking about going into this kind of mini project of building an authentication system. And I did some of the high level things that make authentication systems hard. But in this video, I wanted to dive into some of the more nuanced things. The first one that comes to my mind that makes authentication hard is just that there are a lot of moving pieces. So to build a really good authentication system, you're building not only the code that provides, say, a web interface for people to enter their username and password into, but you're also dealing with things like email, because you do need to get registration links and password reset links and that sort of thing out to people. You might be dealing with text messaging, and that's another system. And then if you're using two-factor authentication or multi-factor authentication, which to build a really good authentication system you should absolutely be doing, that's yet another system that you need to work with. So there are just so many moving pieces that go into an authentication system that it's hard. There's so many things to keep track of. The next thing that makes building an authentication system harder than maybe your typical web application is that you're dealing with sensitive data. So you're not only having to think about, obviously you want to run on HTTPS, use SSL for the tokens going in and out, but you also need to think about how you're storing things in the database and how you're protecting those databases at rest. So things like making sure that you hash the password. That's the bare minimum. But then also thinking about what hashing algorithm you're using. And the recommendation for that changes over time. As computers get faster, it becomes easier and easier for them to compute hashes faster. And in some cases even brute force the hash that people are using. So back in the day, MD5 was considered a good hashing algorithm, and because of a combination of things that have happened over the last several years, it has been determined that the hash can be predictable, which is bad. That's a kind of science has determined that the hashing algorithm is actually weaker than we realized it was. And because it's so short, the resulting hash is relatively short compared to some of the newer hash outputs. It ends up being just a weaker hash, easier for computers to compute and potentially try to brute force. So it's weaker from that perspective as well. I forget exactly what the recommendation is right now. For a long time it was bcrypt, with several what they call rounds. Basically it hashes the hash over and over again. I'm not sure if that's still the current recommendation. Don't quote me on that. There are people who do talk seriously about hashing algorithms and security for sensitive data and that sort of thing. But I know bcrypt was the kind of the standard for several years. The other thing that that makes building an authentication system hard is that you're now not only responsible for your data. So I mentioned storage of data, right? But you're not just responsible for the data you're storing on behalf of the user for purposes of authentication, which realistically it's kind of your data, it's kind of the user's data. But whatever that authentication gives people access to, you're responsible for as well. So obviously you want to have information security practices around storing whatever data that is if you're on the hook to store it, so that people can't get access to it via side channels. But if your authentication system is weak, then as soon as that authentication system gets compromised, someone can potentially impersonate users that you're supposed to be properly authenticating against, or for/against. And if they can impersonate a user, that means they can get access to the data through the main channel, through your web application. If your authentication system is the gatekeeper to your application. So if your authentication system gets compromised, your entire application is potentially compromised. And finally, the last thing that makes building an authentication system hard is the nuance involved in what should and should not be possible through an authentication system. So we all think about the happy path of I type in the correct username, the correct password, and I get access to the thing. I get authenticated. It tells me I am a known user, and I can get through the application, or I can get into the application through the authentication system into the application. That's good. However, there are lots of side paths, not happy paths, right? So there's the obvious case of bad username, bad password, right? That should not be permitted, right? You should at the very least not allow someone any further. But what's really not obvious to in most scenarios is the error messages that you present when one of these exceptional paths occur, because in some cases they can be used to further attack your system. So in the last video I mentioned something called username enumeration. This is basically it's most commonly an attack on the reset password form. And basically what happens is an attacker will type in a username, usually in an automated fashion, and see what error message comes back. If it's an error message like you will receive an email soon, where if they type in a username that is totally bogus, they get a message like username not detected in system. Well, now they can tell that there's a difference between the error message that comes back when they or the message, it's not an error message, the message that comes back when they type in a valid username versus a username that's not known to the system. So they'll just keep typing in usernames and checking for the success message that an email was sent to the user versus the no username known to system, and basically make a database of all of the usernames that they got the success message for, and ignore all the ones that they got the failure message for. And now they can use those known usernames that they know exist in the system, and further attack the system, try to guess passwords, that sort of thing. The same sort of thing can happen with a login field or a login form. And the basic way to protect against that is you want the code to take just as long when a user exists versus when a user does not exist. Same amount of time, same error messages, all of that. So two examples. One example is if the user exists in the system and and they type in the wrong password. So first off, you do not want to go to the database and look up whether the user exists. Maybe you do. Sometimes you do, because typically there's a salt that you do need to look up, right? So you need to make sure that query takes the same amount of time regardless of whether the user exists or the user doesn't exist. Now the next step is you don't want to short circuit if the user does not exist, because then if you short circuit when the user does not exist, that request might happen instantaneously, whereas if the user does exist, you get the salt back, you try to hash the password, then you go to the database a second time, then that obviously takes longer. And if you delay, even if you use the same error message, which that's example number 2, you should always use the same error message. regardless of how authentication fails. So you have one of two options. You have user is authenticated, or user gets specific error message. And ideally, they take the same amount of time. So basically, as you go through your authentication routine, you should look the user up, get the salt back. If you don't get a salt, just make one up, something totally random, right? Something that doesn't introduce additional computational time is preferred. And then hash the password that came in with the salt, and then do another database lookup with username, hashed password, and what you're looking for is find the record, the one record where username equals username users that the web user provided, and password hash equals the password hash you computed, which might be something totally bogus, right? If you used a totally totally bogus hash, it's going to be something totally made up. Find me the one record with this username and this password hash. If none exist, for whatever reason, you don't care why they don't exist, whether it's because the username doesn't exist, so the password hash is totally made up, or the username does exist, but they entered the wrong password. One way or another, you're going to get an empty result set. You're not going to get a user return. In either of those cases, your error message should be unauthenticated, unable to authenticate, invalid username and password, a specific username, a specific error message. But it should always be the same error message, regardless of whether the username is not known to the system or the password is not right for the user that just tried to log in. So that's kind of a deeper dive on that side of things, but there are some really nuanced aspects to that side of user authentication. So moral of the story, user authentication is hard. As I said in the last video, the recommendation is definitely that you don't build your own authentication system. There are authentication systems out there. There are even open source ones. There are services that will do it for you. Even if you don't want to go the route of log in with Facebook, log in with Google, log in with Amazon. Sure, you can go that route, but there are definitely valid business cases not to go that route. You can use something like Okta or OneLogin, I think, is another company that does something similar. Or you can use a library that provides authentication for your platform of choice. If you can do it, use a library that does authentication. That being said, in the next several videos, we're going to continue to dive into some more aspects of authentication, and eventually on this channel we will build our own authentication system, keeping in mind everything that I've talked about. I'm not exactly sure when that's going to be, but it will be coming up probably in the next few months. So be sure you're subscribed, click that notification bell so you'll know when that video or series of videos is released. I look forward to doing them, and I look forward to having you along for the ride. So make sure you're subscribed. If you like this video, hit that thumbs up button. If you have other thoughts, comments, questions, go ahead and leave them down in the comments below. I love reading them. I love responding to them. I really appreciate all the feedback that I've been getting on my videos, and I hope that you are one of those people. Thanks for watching, and I will see you next week.